In this video, you will learn everything about PowerShell remoting. It doesn't matter if you are a PowerShell rookie or a PowerShell veteran, you will definitely learn something, I guarantee that. I will show you every single way it exists to configure PowerShell remoting. Windows server or Linux servers, Workgroup or in an Active Directory, one machine or multiple machines, remoting using HTTP or HTTPS, and remoting with OpenSSH. I will cover the whole spectrum of PowerShell remoting. Hey guys, I'm Stefan and welcome to my basement. I'm a former PowerShell MVP with over 15 years of experience in automating everything I can using PowerShell. We're going to configure PowerShell remoting using scripts, GUIs, or group policies. We're going to tackle everything. And while we're all doing that, we are finally answer the question, is PowerShell remoting actually secure? And in the process, I will share with you tips and tricks that I have learned over my 15 years of experience working with PowerShell in the field. We will do everything. I will show you the theory and how to do it. So stay tuned and let's start. You might ask, Stefan, what is PowerShell remoting? Well, it's pretty simple, really. In a nutshell, PowerShell remoting is the method that allows you to execute one or multiple commands or scripts from one machine onto multiple machines over the network. PowerShell remoting is heavily used in enterprises for mass management. It allows to manage from 10 to 100 to even 1,000 machines all at the same time. But first, let me explain some of the basics. PowerShell remoting is built on WS management, commonly known as WS-MAN, which stands for Web Service Manager. It is a remoting protocol created by Microsoft, which uses SOAP, a firewall-friendly protocol, over HTTP or HTTPS to transfer messages over the network. So remoting works on port 5985 for HTTP and 5986 for HTTPS. These ports are standard defaults. They can be changed, but this is not the topic of today. We will see later on in this video what the difference are between HTTP and HTTPS. When would you like to use one versus the other one? And we'll also answer the terrifying question of,
is WinRm actually secure?
Even on HTTP, the simplest form of PowerShell remoting is the one called built-in remoting. Built-in remoting is the remoting component present in many official out-of-the-box commandlets shipped by Microsoft. It allows you to do remoting using a parameter called computer name. Built-in remoting will work instantaneously out of the box without you having to configure anything. Well, it depends on your network environment, of course, but theoretically, it should work out of the box. In this example here, you can see that I'm using get hotfix in order to connect to a remote machine, using the -computer name parameter in order to connect to a remote host and list all the installed Windows updates. Although we do remoting administration tasks, this is actually not PowerShell remoting, as here we're using another protocol called RPC, or Remote Procedural Call, as its underlying protocol. Also, built-in remoting is actually present in a very small and very limited amount of commandlets. And on top of that, it depends which version of PowerShell you're using, specifically PowerShell Core and Windows PowerShell. The list of available commandlets are not the same. But to make things more easy for you guys, I've put a link in the description down below, which will contain the list of all the built-in commandlets that come with built-in remoting support. But I will invite you to click on this link after you finish watching this video. PowerShell remoting is disabled by default on Windows client operating systems, such as Windows 10 and Windows 11. But did you know that PowerShell remoting is configured and enabled by default on Windows Server operating systems? That's pretty cool, right? It is super easy to enable. In order to enable PowerShell remoting, you have to use one single commandlet, and it's called Enable PS Remoting. It is super easy to enable PowerShell remoting on your machine, and you can do that directly in PowerShell. Open a command prompt and write Enable PS Remoting and press enter. There you have it. That was quite easy, right? Before we look at what Enable PS Remoting actually did under the hood, let's take a minute and look at this most common problem that people face when they use enable PS remoting for the first time. Sometimes we can have the following error message: WinRm firewall exception, blah blah blah, and don't blah blah blah. Read the error message carefully, because the answer is actually in the error message. It actually says the firewall exception could not be created. What does it mean? How do we solve this? Well, actually, the answer to this question is actually again in the error message. It actually says it right here. Change the network connection to either domain or private. This is pretty easy to fix, you will see. We can fix it in two different ways. There is the good way and the not so good way. The good way would be to use the parameter skip network profile check on the enable PS remoting commandlet when you execute it. The better way though would be to go and switch the connection type to either private or domain, because this has a direct impact on enable PS remoting not being able to create the firewall exception that it needs. So now let's go back to what enable PS remoting actually did on our computer. If we have a closer look, we can see it did the following three things. One, it created a firewall exception. In this case, we can see it opened a rule for the port 5985. The second part is about the WinRm service. It started the service and set its startup type to automatic. And the third part is the HTTP listener, which it went and it created for us in the background. Now, configuring this for a single machine is nice, but it won't scale very well, specifically if you do not have another type of remoting capability available to you. If you work in an enterprise, chances are big that you are working within an Active Directory domain. And when we talk about Active Directory domain, we very often talk about, yes, you're right, GPOs. So let's enable PowerShell remoting via GPO. Let's first create an empty GPO. Then we're gonna go and open the group policy editor. In this new group policy, we want to configure two things. One, the WinRm service. We want to enable allow remote server management through WinRm to be enabled. This will enable the HTTP listener for all the machines that are affected by this group policy. It will create a listener that will listen on port 5985. We can specify an IP address that we would like to listen to, or if we open and we want to listen to every IP address, we can just put a star in that box. After that, we want to configure the WinRm service itself. We want to enable it and set it to automatic. Like that, at every reboot, it will be started and available to be used. Last but not least, Windows Firewall. They would like to create a new firewall exception. And for the HTTP listener, which is the one we actually configured right now, there is a predefined rule that we can simply enable. So for HTTPS listeners, you will see there's no existing default rule that we can simply enable. For that, we will need to create it ourselves. Now that we have seen how to configure PowerShell remoting on a single machine and how we can potentially configure PowerShell remoting on multiple machines, let's go ahead and try things a little bit out. Hey, Stefan, what are you doing? Oh, you want a break? Yeah. Yes, I agree. You actually deserve to take a break. I'm gonna explain how to use the remoting commandlet, then afterwards you take over and you explain them how easy it is to configure an HTTPS PowerShell remoting listener, and on top of that you take over the explanation of the OpenSSH. Okay, sounds like a plan. Let's do it. The first command I would like to have a look at is Invoke-Command. Here we use the parameter name, computer name, with the server that we want to connect to, DC001. We give him a script block and a credential and we can connect. We can reuse the same code, simply change the computer name and we will be able to target another server using the same credentials and the same script block. Second commandlet is new PS session. Here, this allows actually to create a session and to save it in a variable for future reuse. In this case here now, we can see that I'm recalling again Invoke-Command. I'm removing the credential parameter. I am passing the variable session to the session parameter. Now we can create a second session to another computer, in this case DC001. We can see now we have two different sessions that are open. Now, where it becomes to be really interesting is that we can add those sessions into an array. And so we can see we have the two sessions in that current variable. Both of them are currently open. It is possible now to execute a script block, here in this case get hotfix, and we give it the array of sessions. What will happen here is that we can see it will go ahead and execute get hotfix on both of the servers at the same time, and we get the data back at the same time. That is pretty cool, right? And last but not least, enter PS session. You will see here we have our open session, and I'm currently connected on DC001. I can enter in the PS session using enter PS session, and if we check the computer name, it is SRV001. At the very left, we have an indicator in which session we currently in. Here we can see we're currently connected on SRV001. We can check for data using any command that we like, and once we're done, we simply exit the session using exit PS session. And once you're done, you can close and remove all the sessions using remove PS session. Okay, looks like I'm done here. Stefan, I give the stage back to you. I think you wanted to show something about HTTPS, but I believe you wanted to talk about trusted hosts before that. Now, before I show you how easy it is to configure PowerShell using HTTPS, to address one caveat that exists with PowerShell remoting. Don't worry, nothing too big specifically that I will show you how to fix this issue so that you won't face this problem in the future. And this problem is called serialization. It's actually not a problem per se, but you have to know the process so that you can use it correctly. So let me explain what I mean by that. PowerShell remoting will rely on WSMan, and WSMan implements the SOAP protocol. And SOAP tells us that when a message is transferred over the network, it must be converted to XML. This facilitates the transport of the message from point A to point B. This conversion from a PowerShell object to the XML structure is called serialization. The raw command is transformed in XML. The XML is sent over the network, and when it arrives on the destination, there's the inverse process that gets executed, and it's called deserialization. It's the matter of converting the XML data structure back into a PowerShell object. All of that is done for us by PowerShell itself. For us, under the hood, nothing to do. We can just use it. If you're more curious, you can have a look after this video at the command that's import CleXML or export CleXML. So this is the magic behind PowerShell remoting, or WSMan if you will. This ease of use comes with a drawback. It is not possible to transfer complex data structure over the network. So let me explain what I mean by that. In this example right here, we're fetching the audio service locally on this machine, and we're just displaying the message. So we can see we went and we fetched the status of the service locally on this machine. And when we look at the status, we can see it's stopped. Now, if we go and inspect that variable using getMember, we can see that the type of object that we have is of type system service. That is very important. We can see right here that no serialization took place. That means we have access to a bunch of methods such as start, refresh, etc. So now, if we go and execute the same command remotely on our distant session using Invoke-Command, what will happen is that under the hood, our object, our command, will be converted in an XML structure. This XML structure will be sent over the network to a remote machine, and it will be deserialized on the remote machine, and the command will get executed there. Command will be executed, and then it will be serialized again and sent back over to the network to our original host. Over there we can catch this value and we save it in a variable. Now if you look closer at the contents of that variable, you can see that, for example, if we try to stop it, it will not work. And this is the drawback of serialization. So why is that? If we take a closer look at the contents of this variable, we can see that we are missing those methods that we saw before, like stop, start, refresh, etc., and many more. And so if we go have a look at the type of object that we receive back, we can see that the object is now of type deserialized.system.service. And so this is what I mean with we will lose some functionality. We will lose methods that are attached to our object if we use remoting and if we are not smart about how we write the code that we use for remoting. And so there's a solution for this, and I just said it before. Let's be smart by writing this code that we're going to be using in the remoting session. So how we do that? So it's very simple. Instead of wanting to stop the service locally on our machine, let's stop it and do all the actions we want to do with that remote service remotely in our remote session. And actually this makes sense, but sometimes it did not. So do all the things you need to do on the remote machine, on the remote service, in that remote script block. Write all your code for that remote session in that remote script block, and then execute it and send only the results back. And this is serialization. And now with all of that, it is finally time to have a look at remoting using HTTPS. If you have been watching up until now, that means that you have had some added value by watching this video. It would mean the world to me if you could hit the like and the subscribe button. This really helps out to put this message in front of other viewers just like you. And so here it is. Finally, we have it. We finally gonna answer the question, is PowerShell remoting actually secure? And I'm gonna cut straight to it. Yes, it is. Okay, but why do we have HTTPS then if WinRm over HTTP, so the basic version, is already secure? Well, that's a very good question, and I'm glad you asked it. Let's have a look, answer this question right now. Let's have a look at what WinRm actually is. We know that WinRm is Microsoft implementation of the WSMan standard. It is used for managing and monitoring devices remotely and relies on a client-server-based model. We already know that WinRm, or actually WSMan, implements SOAP, that protocol that tells, hey, we need to transfer our messages in XML format. And so what we didn't know yet, or at least what I did not tell you guys yet, is how this XML is being transferred over the network. And that is being done using protocol like HTTP or HTTPS. WSMan will ensure security of the message being transmitted by encrypting the message prior to sending it over the network. Then the next logical question would be, how does it encrypt it? The logical answer would be, it depends. The message level encryption is defined by the initial authentication protocol that is being used when they establish this connection. Different authentication methods provide various levels of encryption. In a nutshell, there are 4 encryption levels that are important to us. 1, using Kerberos, aka being part of an Active Directory domain. When you're part of an Active Directory domain, the encryption is defined by the E-type in the TGS ticket, which is commonly AES 256. When using NTLM, aka being in a workgroup, or when using an IP address to create the connection, it will use RC4 cipher with an 128-bit key. So although this is encryption, it is known to be a weak encryption. So if you can avoid it. And for CRED SSP, encryption is defined by TLS cipher suite, which is negotiated during the handshake when the HTTP or HTTPS connection is established. And then there's basic authentication. When using basic authentication, you're basically disabling the message encryption of every SOAP message, and you're just sending data in clear text. If you want to do that, maybe for test reason, or maybe you have other reasons to do it, Microsoft doesn't make it easy for you to do. Using basic authentication in a production environment makes probably no sense, but you can still do it. So to sum it up, is WinRm secure? Yes, it is. Your packages, when they will be sent over the network, they will never be unencrypted, except if you enable the basic authentication method. Please don't do that in production. So yes, packages will never be sent unencrypted over the network. The WS-Man will always encrypt packages before sending them over the network. And the level of encryption that this package has depends on how those two systems have authenticated. So one of those four values over here. So in a nutshell, if you are an Active Directory domain and using WinRm over HTTP, the regular one, this is way more than enough. As soon as you need to communicate outside of the boundaries of your Active Directory domain or in between workgroups, then HTTPS becomes the logical next step for your production and secure communication scenarios. When using PowerShell remoting with HTTPS, the individual messages that will be sent over the network will still be encrypted. But in addition to that, we're going to have the HTTPS tunnel that's going to be created, which will ensure that the transport layer is completely encrypted. And in that transport layer, the encrypted message will travel. And in addition to that, in order to use HTTPS, you need to have a certificate. And this certificate must be delivered by an authority system that you trust. And in the end, it verifies the identity of your client and your server, and it proves, the certificate proves that the machine you're talking to is really the machine that you are talking to, and not a man in the middle. So enabling HTTPS will also help you prevent man-in-the-middle attacks. Now we're going to configure WinRm over HTTPS, and after that, we're going to have a look at OpenSSH. So in order to configure WinRm to use HTTPS, we need to create a new listener. So first, let's list the listeners that are currently available to us in this specific machine. So we can see here that we have one listener right now. It is enabled and its transport mechanism is HTTP. And by the way, I will put all the commands I type with code examples down in the link in the description below. So in order to use WinRm over HTTPS, we need to have a certificate. And we can create a certificate using two ways. First would be that way, which is a self-signed certificate. And then the second, the good way, would be to ask for a certificate at your certificate authority, so at your PKI, or even buy one online. So in order to create a new self-signed certificate, we can just use the new self-signed certificate commandlet. In order to create a new listener using the HTTPS transport mechanism, we can use WinRm quick config and specify the transport to be HTTPS. It will detect automatically an existing certificate in your local certificate store. But as you can see right here, this will not work. Why did it not work with WinRm quick config transport HTTPS? Well, the solution is in the error message. You cannot create WinRm listener because this machine does not have an appropriate certificate. And why is that? It mentioned it here. A certificate must have a CN matching the host name. It must be appropriate for server authentication and not expired. And it cannot be self-signed. And this is exactly what we're trying to do. So, Stefan, that doesn't even work your solution. There's another way to do this. So, does that mean we cannot implement a self-signed certificate for HTTPS? No, we can. And so, why do we have this message in the first place? Well, for security reasons. Everybody can create a self-signed certificate. It is a best practice to go request a certificate at your PKI, which we'll cover right after this part. But if you're doing this in a lab environment, just for testing purposes, this is fine. So we need to identify the thumbprint of our certificate, and then we can go ahead and create listener using new item. and we will create the listener in the WSMan store, and we will specify the thumbprint of our self-signed certificate as certificate thumbprint parameter. And if we go ahead and list the current available WinRm listeners, we can see that we have now two listeners, the HTTP and the HTTPS one. Notice as well that we did not configure anything. The HTTP listener will listen on port 5985, and the HTTPS listener, which we just created, will be listening on port 5986. If you remember earlier when we configured PowerShell remoting using quick config for the HTTP scenario, so basically WinRm out of the box, at that moment it created for us the firewall exception. In this case here, HTTPS will not do that for us, so we have to create it ourselves. So this is pretty straightforward. We just go ahead, create a new firewall exception. We give it a useful name. The firewall exception must be for TCP on port 5986. Of course, we want to allow the connection. We can specify which network we want it on. Here we got to select it all. And that's it. If we go have a look now, we can see that our new firewall exception is created and available. So if we want to go one step further, we can go ahead and actually remove the HTTP listener. This would be perfect for systems that need to be highly protected, highly isolated, or for example, banking systems or anything that is important in your field. And we can do that by simply deleting the HTTP listener on the WSMan provider using the command that I'm showing right now. If we list the listeners right now, we can see we have only the HTTPS listener that is available. So now let's go ahead and test this connection. So this system is part of an Active Directory domain. I'm just fetching the credentials. And so I use new PS session in order to open a session to my remote machine. Here we have it again, another error message. And the error message doesn't go blah, blah, blah. Read the message carefully again. It says it right there. The SSL certificate is signed by an unknown certificate authority. In other words, this means Windows does not trust this certificate, and it will prohibit you to use it for more security. You can still use it if you want, but you need to go ahead and tell them, hey, it's all fine. I'm actually okay with using a self-signed certificate. And so here we create a new option using new PS session option, and we specified the -skip CA check, which basically does what it says. It will avoid the check for the CA. And now we attach this option to our previous command and we execute it again. You will see that it creates the connection now to the remote machine. We can see that the session is now open, and we can enter into our session using enter PS session and execute some command, and we can see here that we are on the server Win103. On this machine, we can also list the open TCP connections. And if we have a closer look at this, we can see that the connection has been done over the port 5986, which is our HTTPS listener port. Now that we have seen how to use PowerShell remoting using HTTPS with a self-signed certificate, let me show you how easy it is to configure PowerShell remoting using HTTPS with a valid certificate which has been provided by your PKI after configuring HTTPS. I want to show you how to use PowerShell remoting in Workgroup outside of your Active Directory boundary. And then we're going to tackle OpenSSH for Linux machines and for Windows machines. So stay tuned. So in my lab environment, I do have a PKI, and we are going to go and request a new certificate. So this certificate is not going to be self-signed. It's going to be signed by my public key infrastructure. For that, we open the local certificate store. We go to personal certificates, all tasks, and request a new certificate. Here we select Active Directory enrollment policy, click next. Out of the list of types, we select computer. Here, in this case, that's the only type available to us, so we just go ahead and select computer. And that was it. Now we can see that we have a new certificate in our store, which has been issued to this specific server. On this server, if we list the listeners that are currently present, we have only an HTTP listener And now using WinRm quick config transport HTTPS, and will ask us to confirm that we really want to create the HTTPS listener. We say yes, and voila, that was it. Easy, right? So let's list the listeners. Let's be sure that it created the HTTPS listener, and it actually did. We have the HTTP listener and the HTTPS. Now let's go ahead and try this connection. So right now I'm going to try to use the dash use SSL parameter, but I'm using an IP address. It will refuse to establish the connection. But why? So now you know it. Don't buy the error message. Read it carefully. It says here that the default authentication mechanism may be used under the following conditions: if the transport is HTTPS or the destination is in the trusted host, and if explicit credentials are being passed. And by the way, we're gonna talk a little bit more about trusted host in just a few minutes. So if we're using now the FQDN, the machine we're trying to reach, then the connection is actually established. Go ahead and connect to the session, and we can list the current open TCP connections. We can see that the TCP connection on port 5986 are currently open. And so here, just a little bonus, because I'm a friendly person. PowerShell remoting requires local administration privileges in order to be able to create a remote connection. If you do not want to provide local administrator privileges, then you can actually create your own remote access group, maybe one for all the machines and specific ones for specific machines, and deploy these groups using group policies. What you need to do is simply add that group in the remote management users local group, and you can then remove that specific account from the local administrators group. Exactly what I've done here. Thank you. You're welcome. So that was it. We've seen how to configure PowerShell remoting using HTTPS with a self-signed certificate and using a certificate provided by your local PKI. It was easy, huh? I told you so. Before we look into configure PowerShell remoting using OpenSSH to have communication between Windows and Linux machines, there's one part I would like to cover first, and that is using PowerShell remoting in a workgroup. Inside an Active Directory domain, you can trust the identity of the servers to which you try to establish a connection, because there's an authority, the Active Directory domain, which is going to validate the identity of the servers of its Active Directory domain using a protocol called Kerberos. This basically means that PowerShell remoting will allow you to access the server as soon as Kerberos allows it. If you try to reach a server that is located outside of your Active Directory domain, PowerShell remoting won't allow that by default, because it has no way of trusting the identity of the server that you are trying to reach. For that reason, PowerShell remoting cannot use Kerberos even if you are located in an Active Directory domain. In that particular case, it will fall back from Kerberos to NTLM. And so for these computers that are located outside of your Active Directory domain, PowerShell has a mechanism called Trusted Host. It is somewhat an extra layer of security. You can specify servers in a specific list. In a nutshell, if you try to connect to a remote machine located outside of your Active Directory domain, PowerShell will first check if that server is part of the trusted host list. If it can find the IP address in that list, it is all good. It will let you go ahead and connect remotely to that system, but it will use the NTLM protocol. Now, on the opposite, if the server is not listed in that trusted host list, PowerShell will not allow you to connect to that remote machine. I want to show you first that I actually have connectivity to this client. The next logical step now would be to enable PowerShell remoting on this freshly installed machine. For that, we simply call enable PS remoting using -force and skip network profile check. Once that is done, we go back to our server and we try to invoke the command to this specific host with using the IP address and the pre-recorded credentials. So we can see here, again, we should not blah 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 the error message, because it is explained in the error message what the problem is. So all we have to do is read it and take action on it. It basically says that here, the Windows client cannot process this request. Default authentication may be used with an IP address under the following conditions. The transport is HTTPS, or the server is located in the trusted host list. It also mentions at the very end that these servers might not be authenticated. What it means by that is that even if those servers are located in your trusted host list, it might not mean that these servers are really trustworthy. So the different ways to add servers in the trusted host list, the one that I use the most is using setItem and the WSMan drive. You basically use setItem, you point it to the path, WSMan localhost, client, trusted host, and you add the value of the IP address to which you want to connect to. You can see that after that, the connection actually works. To remove or to clear completely all the items from the trusted host list, the only thing we need to do is call clear item and give him the path and press enter. I would like to mention also that all the extract, every single line of code that you can see during this whole video will be available in the link down in the description below. Now it's the time to talk about cross-platform communication. In order to be able to communicate with Linux systems or macOS systems, Windows has the capability now to use OpenSSH. OpenSSH is a critical tool for administrators, specifically in the Unix and macOS world. It operates on port 22, and this also applies to PowerShell over OpenSSH. SSH has been added in Windows in autumn 2018. This means it is present in client operating systems from Windows 10, Windows 11, and since Windows Server 2019 and above. The new thing here, recently it was announced that in the next server version of Windows, so Windows Server 2025, OpenSSH will be enabled by default. You will see that in the current operating systems, OpenSSH has been made available, but it is an optional feature that we need to install. SSH has two ways of working. One, using a passphrase. Two, relying on public and private keys. One of those systems has a higher level of security, but I will let you guess which one of those two solutions has the highest level of security. How does the client authentication actually work when we use OpenSSH? Before we go into the details of how to set up OpenSSH on a Windows machine, I want to go ahead and explain the theory that relies behind using SSH in general. Specifically, if we're using private and public key pairs. Just so you know, it is also possible to use a password authentication, which I will show you also just a minute. On the SSH client, you go ahead and generate two keys. These keys are commonly known as a public key and a private key. The public key is something you can share, everybody can read it, everybody can know that it exists. The private key, though, is a secret. It should be considered as a secret and it should never be shared. The public and private key are related to each other. You can go ahead and using a private key, you can calculate the value of the public key, but not vice versa. If you just have the public key, you will never be able to calculate the private key value back. The server will try to connect to a remote endpoint where OpenSSH is installed. It will go ahead and do a request generally on port 22. When the server receives this connection, the server will go ahead, generate a random number, calculate the MD5 hash of that random number, encrypt the number using the public key of the client, and send this encrypted random number back to the client. Once this client receives the encrypted random number and try to decrypt it using its private key. Once it managed to decrypt it, it will go ahead and generate the MD5 hash of the long number that it just received. They will compare the MD5 hashes that they have. If those MD5 hashes matches the one from the client with the one from the server, then the connection is established and the client and server will trust each other and the communication will be allowed. The connection is then open and messages can be sent between the client and the server. Yeah. And that's it. So now that we've seen that, let's see how we actually go ahead and install OpenSSH on a server and on a client, and how we configure it. So there are two scenarios here I would like to cover. One, the connection of using OpenSSH on the Windows perspective, and the second part will be the Linux perspective. So on a Windows server, the prerequisites are minimal. You need to install the OpenSSH feature. So if you take a look now, you can see that we have two optional features available. We have this OpenSSH server and the OpenSSH client. You have to install the OpenSSH server on the system that you would like to connect to remotely, your destination host. The OpenSSH client is the optional feature that you need in order to be able to establish a connection. But nonetheless, the client should be installed by default. We are going ahead and installing the server version here. And that's basically it. If we have a look at the firewall rules, we can see that it created an inbound rule for port 22 on TCP, which is the default port of OpenSSH. It additionally installed a service called SSHD, D for daemon. Daemon stands for service in the Linux world. So that service is by default stopped. We need to start it, enable it, and set startup type to automatic. As soon as we start the service, we can go ahead and have a look at C program data /SSH. And in there, we're gonna have a lot of files that are automatically going to be created. These files are important in order to be able to configure the different options of OpenSSH. Within all those files that have been created in that folder, there's one that is pretty important for us, sshd_config. This file allows us to configure all the options that are available in OpenSSH. I'll tip, everything in the Linux world is case sensitive. So here we want to configure two things. One, we want to enable the password authentication, and two, we need to add the PowerShell subsystem. And I will come back to that in a second. To enable the password authentication, search for, you guessed it, password authentication. And make sure that the line is not commented and that it is set to yes. Before using PowerShell, in order to use SSH, we can actually use pure SSH if you want to make sure that the OpenSSH communication actually works. This is generally a good practice if you need to troubleshoot remoting problems, issues with OpenSSH. When launching the connection, the first thing that will happen, if it did not already occur, it will present us a key fingerprint and ask us for confirmation to connect. If we say yes, the fingerprint will be added to our known host list. The known host is actually just like the trusted host, but instead of writing down the IP address or computer name, it will add the SA key fingerprint. You can see that we are connected now on the system using raw SSH, and we are actually using a command prompt. If you want to continue to use SSH, but you would like to use PowerShell in your SSH prompt, that is actually possible. We can change that. We simply need to set following reg key, which is a value that points to the path of PowerShell 7. So PowerShell core, or in other words, PWSH. So now let us connect to that remote machine using PowerShell instead of SSH. Do you think that it will still work? Let's give it a try. So the process to connect to a remote machine using OpenSSH is very straightforward. And if you're pretty familiar already with using Invoke-Command, enter PS session, etc., well, you will feel just like home because it uses the same commands. You've learned it once, you can use it multiple times. Starting with PowerShell 6, a new parameter has been added to Invoke-Command, enter PS session, new PS session, and that parameter is called hostname. So hostname is the parameter that you need to use if you want to open an SSH tunnel to a remote machine. PowerShell knows that each time it sees the parameter hostname, it should not use classic WinRm, WSMan in other words, but it has to use SSH. So let me show this with a concrete example how this works. And so in this example, we can see that I get an error message, subsystem request failed on channel 0. This is a common error that can happen if we do not configure OpenSSH completely. I specifically show it to you because it happened to me and it most likely will happen to you. So this is how we fix it. Simply go back into the sshd_config file and make sure that a subsystem is actually present in that file. And if it's not, add the following line. You can find everything in the description below into the config file. So once we've added the new subsystem, we need to restart the SSHD service and we can try again. If you have allowed the password authentication and if you've added the correct PowerShell subsystem in the sshd_config file, then you should not have a problem to connect. Well, you still need to get the password right. And voila, that's it. That's the only thing we need to do in order to be able to connect to a remote machine using OpenSSH. Easy, right? Let's level up our game now. Start to use cryptographic keys. You'll see this feature is pretty interesting, so stay tight. So in order to use public and private keys, we need to tell our SSH server that we actually want to enable this feature. So how do we do that? We go back into our sshd_config file and we simply say we want to enable it. And we search for pub key authentication. We make sure it sets to yes and that it is uncommented. So let's restart the service and try to connect to it. If we connect now, we can see we have another error message. So no blah blah. Here we can see permission denied, public key. This makes sense as we've never created any key whatsoever. We just enabled the public key configuration in the SSHD config file and that's it. So let's go ahead and create some cryptographic keys. So we need a pair of public and private keys. We can use SSH keygen.exe in order to generate those ones. We can simply leave all the options to the defaults. We can see that SSH keygen generates 2 keys in the .ssh folder of our documents right here. There is a public key, the id_rsa.pub, and there's a private key, the id_rsa. So this private key should be considered as a secret. The contents of this file should be copied out, placed in a credential management system, and this file should be deleted. So we need to bring the public key to the remote server where we want to connect to. I'm here using RDP and simply using a simple copy mechanism. SSH comes with a handy built-in tool called CP, which is a secure copy file mechanism, which is commonly used to bring SSH keys over to remote systems. The contents of this file needs to be copied over to our remote system into our SSH folder called authorized_keys. If you want to give administrator access to people using this key, you need to add an additional step and you will need to copy over the contents of this file into another file called administrators_authorized_key. Additionally to that, you need to disable the inheritance on that specific file and make sure that only the administrators and the system account have full control on this file, and set the owner of this file to the local group of this server. Validate everything and restart the SSHD service. I like to test things first using pure SSH. Here you can see I'm using the -i, which stands for identity file, which allows to specify a private key that we would like to use. In this case, I've only one available, so I will point to that one too. Okay, now that we've tested a connection using SSH, let's go ahead and start using PowerShell and establishing a connection using SSH instead of WinRm. You will see you can actually use the exact same commandlets to manage your connection that you have open using OpenSSH, just as you would with the connection open using WinRm. It's possible to use new PS session, and you can specify here the -key file path, which you have to point to your private key. So you can go ahead and create this connection to your SSH server. Now that the connection is established, you can see, if we have a look at the session variable that we created, that the connection is now open and that the transport type is of type SSH. Pretty cool, right? We can go ahead and use that session to enter the session using enter PS session, launch a few commands. We can see that it works just as it would with a regular WinRm connection. And once we're done, we can just simply exit this session using exit PS session. And once you're done using this connection, you don't use it anymore. Just as with WinRm, you can go ahead, remove the session using, you guessed it, remove PS session. So passing a key file is the solution. It is simple, but clearly this doesn't scale. Also, it can be a bit annoying if you need to pass the right key to the command each time you want to connect. But without a doubt, it is much easier than to pass credentials each time we want to connect. So we can actually use a command that will add a key to SSH, and SSH will keep it in memory in a secure location. He won't ask for it again in the future. And this command is SSH add. You will see that when we try to connect again, we do not need to use -I, and we can connect directly without specifying either credentials nor a private key. That's pretty neat, right? Let's have a look and configure partial remoting for Linux systems now. Here we are on our Linux system. This is an Ubuntu server. Let's first make sure that we have installed the SSH client and the SSH server. For that, we use sudo to install OpenSSH client and the OpenSSH server. Now, this is going to be similar on the Windows systems, but we're going to do everything on the Linux system. On your OpenSSH server, so the system to which you would like to connect to, go ahead and open the sshd_config file, which on an Ubuntu system is located by default in e/ssh/sshd_config. So we're now located in Vim, which is a text editor on Linux. It is a bit special, so bear with me if you're new to this. You need to go ahead and do the following two things. One, we want to add subsystem for PowerShell, and two, uncomment the password authentication and set it to yes. So now press escape followed by WQ exclamation point so that you can get out of Vim. Restart the SSHD daemon. Now let's go back on our server and try to establish a connection to this Linux machine. Here we're going to use new PS session. We specify host name and not computer name, so we make sure that partial remoting will open an SSH tunnel and not a WS-man, and we point it to the right server. It's going to ask us if we would like to add the fingerprint key. We say yes. Voila, we're connected. So now in order to connect to a Windows machine from a Linux host, we basically do the same thing again. It's really straightforward. We open a new session using Invoke-Command or new PS session and establish a connection using hostname. You specify which username you would like to use. In this case, I'm using a domain account from my Active Directory system, and voila. If you like this content, I would recommend you go ahead and look at this video right here or this video right here. Thank you so much for watching and take care.